All right, guys, so the warm-up question says, which could show the velocity time graph for an object in free fall that was dropped from rest? And you have 4 different graphs there, A, B, C, and D. So if you take a look at those velocity time graphs, which one could show something dropped from rest? What do y'all think, A, B, C, or D? I hear a lot of different answers. I think I've heard every letter. All right, so let me start here. Let's see if we can narrow it down. If you drop something from rest, what is its initial velocity? 0. Which means you can eliminate 2 of these graphs right off the bat. Which ones can you eliminate? A and B. Okay, which means it is either C or it is D. Okay, the slope of a velocity time graph, what does that slope represent? Acceleration. Okay, and acceleration for a falling object is due to gravity, and that acceleration for any object that is in free fall is a constant negative 9.8 meters per second squared. It doesn't change. So the acceleration should be the same the whole time, which means the slope should be the same the whole time, which means the only option available to us is C. Okay, the answer to the warm-up question should be C. That is what the velocity time graph will look like for any object dropped from rest. Okay, now on Earth, that slope of that line would be negative 9.8. Okay, if you were on a different planet or on the moon, then it'd have a different slope because their accelerations are different because they have different gravitational field strengths. Okay, we're not getting into that just yet, but this, if we had numbers, would have a slope of about negative 10, negative 9.8 to be more precise. But again, there's no numbers there, but this is the only one that makes sense, okay, is answer choice C. Today you're going to be working on your RA, but before we do that, I do have a little follow-up question for the warm-up. And then you do have homework, and that is your RA specifically. If you don't finish it in class, that is due by 11:59 p.m. tonight. But if you haven't yet finished 202.2, I would also recommend that you take a look at that. And then there is a unit summary posted in Schoology, which is practice. It's also your daily grade redo if you happen to need that. But before we talk about this a little bit more, let's see if you guys can answer this. We haven't talked about this yet, so this is more of a can you figure it out. But it says, what would the velocity time graph look like for an object in free fall that was initially thrown upwards before falling to the ground? So similar to the warm-up question, we had a velocity time graph there, but this time, instead of being dropped from rest, what if I throw it straight up in the air? What can you tell me, what do you think it would look like?
You would have a straight line going away from 0, and then for like a very small like horizontal line, and then it would go back down.
Okay. We haven't talked about it yet, so I'm just curious. Did you have a different guess? Did you have a guess? Okay. So what would my initial velocity be for an object if I threw it upward? What would its initial velocity be? Is it still 0? No. Obviously, if I throw something, its initial velocity is not 0 anymore. So if we threw this object upward, what can you tell me about its initial velocity? It's positive, which means on this graph, you would have to start with a y-intercept that is positive, right? Because that's what it says. If I throw it straight up, it's going to have a positive initial velocity. Maybe I throw it up with a velocity of positive 5 meters per second, and then it's going to go from 5 to 4 to 3 to 2 to 1 as it slows down. And then it's going to reach some maximum height at which its velocity is 0. And on my graph, that means it has to touch this axis. And then it's going to fall back down. So if you threw an object up in the air, and we're going to talk about this more next week, but if you threw an object straight up in the air, that is what the velocity time graph looks like instead. It starts out moving upward, it slows down to 0, it stops momentarily, and then it starts moving downward and speeds up as it falls. The slope's the same the whole time, just like it was in the warm-up, because gravity is the same the whole time. It's negative 9.8 meters per second squared. No matter if it's going up, down, sideways, it doesn't matter. If it's in free fall, that is its acceleration. All right, like I said, we haven't talked about this yet, but I just wanted to see if you guys could kind of reason your way through it. Alright, so for the rest of the class period today, you guys are working on your relevant application, which is due tonight by 11:59 p.m. So you need to open up your acceleration lab if you haven't yet finished it, and that is what you should be working on. If you are already finished with that, and you haven't yet finished 202.2, then I would encourage you to work on 202.2. I did post a new version in Schoology that actually, I think, fingers crossed, that the feedback works on. Mr. Quigley said he was able to take a look at it and get it fixed, so it should be working. So what I'm going to ask you to do is use that one moving forward instead, and in fact transfer your answers over so you can see if they're right or not, because the one you have right now isn't going to tell you, at least not correctly and definitely not consistently, because of the way it was keyed in there. So again, you should have the exact same questions. That should be true whenever you open it up. So work on that new version in Schoology with the fixed feedback and transfer your answers over. So you're going to find it here. Let me just show you what it looks like. If you log in, let me zoom in a little bit. That's too much. Okay, so in this Unit 2 folder, you're going to see it right here. It says Fixed 202. And so if you open that up, you should have that file there. You can click My Document, you can open it. But it should give you the exact same numbers as the original one. If it doesn't, please let me know so that I can fix that. I don't want you having to answer different sets of questions if you've already answered them once. So please let me know. Additionally, I mentioned this already, but there is a Unit 2 summary up here for CFU Redo. It's also a great test review and good practice. So if you're looking for additional practice problems, that is available to you as well. So again, for the rest of the class period today, you can work on your RA. You can instead work on 202.2, or if you're done with both of those things, you can work on your unit summary. But you should be working on those things while you're in class today, and if you have questions as you're working, obviously you can consult with one another and help each other, that's fine, but otherwise make sure that you ask me before you leave so that you're able to get this stuff finished, specifically the RA by 11:59 p.m. tonight.